Okay, now let's go through a simple example problem of how a single crystal could deform under some stress. So what we have here is a single crystal, that's good to know, of some metal, and it has a critical resolved shear stress of 20.7 megapascals. Now it's exposed to a tensile stress of 45 megapascals. So we want to know, will yielding occur when phi equals 60 degrees and lambda equals 35 degrees? And if not, what stress would be necessary? So this would have been taken from whatever metal it is, its slip plane, and its slip direction. You'd have to know that first, and then you could solve. Now remember that your slip direction, that is a vector. You can use your simple dot product to solve for the angle between your normal stress or your force and that slip direction. So don't forget that. Okay, first we have to calculate our resolved shear stress with this, which isn't too bad. It's our normal stress, or our tensile stress in this case, times cosine of lambda times cosine of phi. So we plug everything in there and we say it's 18.4 megapascals. Well, obviously that is actually less than 20.7 megapascals, which is our critical resolved shear stress. We don't have any motion until we reach that critical resolved shear stress, so there will be no yielding. We won't have any plastic deformation. Okay. We want to figure out, well, when will it yield? So we take our critical resolved shear stress and these directions, and that should be equal to our yield stress, because once we reach if our resolved shear stress reaches our critical resolved shear stress, it will begin to yield. And so we're just going to replace our resolved shear stress in the equation with our critical resolved shear stress and solve for the normal stress. If we plug everything in, we see that it would take 50.5 megapascals before we begin seeing some plastic deformation. Okay, now I know that was pretty simple. However, we will be doing other problems in the future, and I'll try to have some examples of this, where I show you a particular atom and a particular configuration, and I say, okay, the force is along this direction. I'll give you a direction of the force, be like, it's along the 001 direction. And you'll have to go from there. So you're going to need to remember that whole dot product that we've done. We've done that before in class, I know, so don't forget that the dot product can give you the angle between two vectors. Magnitude of A, magnitude of B, cosine of, say, that's the angle between the two vectors, is equal to A dot B. Don't forget that. You can solve for it. So that's it for this time. Thank you for listening, and I'll see you all later. Bye-bye.